This video is on special number sets and interval notation. I'm going to start off with natural and counting numbers, and you can see that that is represented by that kind of special N, and all these are represented by this style of capital letter. Now, natural numbers are whole numbers starting from 0 and are positive. So it does include the number 0, and after that it is all positive whole numbers. You can see I've got a number line below there, and the red dots on the number line represent the numbers that are in natural counting numbers, and a little arrow at the top is just telling us that it is going on forever. Next we have integers. Now within integers there's three different kind of little subsets of integers. We have plain integers that include all positive and negative whole numbers, including 0. Then the next one is Z plus, and you can see the little plus there, which are all positive integers, which does not include 0. Because 0 isn't positive or negative, it is kind of neutral in the middle. So Z plus are all positive whole numbers, so 1, 2, 3, 4, and going on from there. And then we have Z minus, Z negative, which are all the negative whole numbers, starting at -1 and carrying on indefinitely, all the way to negative infinity. So with integers, we can have integers as a whole, but we can then also split it into positive and negative. Main thing here is to know that 0 only comes under the overall integer set. It is not included in the positive or negative integer set. Next, we have rational numbers. Now, rational numbers we represent with the letter Q, and it is a set of numbers which can be written in the form P over Q, where P and Q are integers and Q does not equal 0. Putting it really simply, a rational number is a number that we can write as a fraction. So for example, 0.25 is 1 over 4, so it is a rational number. If it can be written as a fraction, it is rational. Irrational numbers are obviously the complement of Q, as we can see there, the Q with the dash, and it is a set of numbers which cannot be written as a fraction. So the square root of 3 is an infinite decimal number when we convert it to a decimal. Same as pi, it's an infinite decimal number. We cannot write those numbers as fractions, therefore they are classed as irrational. And lastly, we have real numbers, which is the capital R, and it is all numbers which can be placed on a number line. So if we can put the number on the number line, it is real, and that's why we represent that. You see that number line there? It is just an arrow above the number line. There's no dots on the number line because it includes everything. So 0.25 can be included, pi can be included, because it can all be placed on a number line. Then here I just have a nice kind of little diagram to show that real numbers is kind of the top. From real numbers, we can split the numbers into rational and irrational. But then with rational numbers, we can break that down into integers and then into natural numbers. So natural numbers are a subset of integers, integers are a subset of rational numbers and irrational are subsets of real numbers, if we bring it back to that set notation. Now from there, we're going to go and look at interval notation. So to avoid having to list all members of a set, we can use a mathematical sentence. Now we have the notation, you can see here I've got these curly brackets, which represent sets, which we've already seen. We've got the X, and we have that straight line. Now if you go back to the previous video and all our notation for sets, that straight line means such that. So that little bit there means the set of X such that, and then we put something else in there. Little example to start with, we have the squiggly line, X, that E. Go back to our set notation, means the element. So X is an element of R. R is real numbers, such that X is between -3 and 2, including 2. Now, that is what that means, and we can write it really quickly in notation. We can write it in words, as you can see below there. We can put it on a number line. There's different ways we can represent interval notation. As mathematicians, we don't like to generally use all the words, like in the black sentence there, so we would much prefer to do it quickly, like in the red mathematical notation or on a number line. Now if we are to put this on a number line, so we've got X as an element of real numbers, which means excellent, we can put it on the number line, but we're going to be between -3 and 2. Now the difference here is -3 is not included, but 2 is. So if it is not included, we just write a circle, and if it is included, we have a filled-in circle and we join them up like that. So that is telling us exactly the same as the sentences above it, that we're looking at all numbers between -3 and 2, but including 2. Now, when we have real numbers and we're looking at a set of real numbers, we can write this in different ways. Depending on what textbook you look at and things like that, you may see this in different ways. So I've got two other options here. So this first one, I'm just going to put a 1 next to it. The only difference here is we're putting the x as an element of r right at the end of the sentence, rather than at the start as we have previously. Now in the second other option, you'll see here we don't have x as an element of r anywhere. And that is because if it doesn't say it, we will always assume real numbers. So if you ever see one like this, there is no x as an element of r anywhere, we assume real numbers. If it's an integer, a rational number, irrational number, it will always tell you. So if it doesn't tell you, it's a real number. Now the next one here, we've got x is an element of z, such that x is between -5 and 5. Now remember, z from before is all integers. So in words, this is the set of all integers, x, such that x lies between -5 and 5. Now once again here, I've got two options of how you could see this. The main difference is this x is an element of z, could be seen either side of the sentence. Now if we're going to put these on a number line, now because integers are set numbers, within integers we can't have 1.5, 2.5, which means we're going to draw our number line slightly differently. So I'm just going to label all the numbers on here, so -5 all the way to 5. Now when we represent these on the number line, we are going to use dots on the line because we have to represent the specific numbers because it can't be anything in between. Now the big thing to look at with this question is are -5 and 5 included? They are not, which means our dots are going to start at -4 and go all the way up to the number 4. The -5 and 5 will not have dots there because in the question they are not included. So always just be careful and mindful of that when you're drawing these types of diagrams, to look at where you're going to start and stop. We don't put any arrows or anything on above this diagram because we are not looking at between these numbers, just the exact numbers themselves. All right, let's have a look here. We've got a few examples of just practicing writing in notation. So the first one, write using interval notation, is first one. So we're always going to start with our bracket, and we're going to say that x is an element of. Now we need to decide, is it real numbers, integers, natural numbers? Here you could do different things because we are going from 1 to 5. So there's lots of different ways you could write this. So you could have done natural numbers, or you could have done positive integers, or you could have said integer. They all would be correct. With this one, I'm going to go with n, natural number, because I'm only looking at from the number 1. But if you had gone z plus or z, you would still be correct. Any of those three are fine. And then we're going to go such that we have that straight line. Now we're going to, because I'm looking at natural numbers, I'm going between 1 and 5. I'm going to go 1 less than or equal to x less than or equal to 5. And close my bracket. Once again with this one, there are multiple different ways you could actually write this and it would be correct. So we could have also done from 0 less than x less than or equal to 5, because 0 is not included, which means in that case it would start at 1. We could also maybe have started at 1 and gone up to less than 6. It would still be correct. So with these situations, there can be a few options. Just do the one that makes the most sense to you and you'll be fine. They would all be marked correct in an exam situation. Now part B, we're looking at when x. Now we need to decide, are we looking at natural numbers, integers, real numbers? What are we looking at? Now because it's a line above, it has to be real numbers, because we had the line above, so it's including everything on that number line. Such that now we know we're going between -3 and 6, and we just need to decide what the symbols are going to be between that. Now we have a coloured in dot for -3, which means it is included. We have an open circle for 6, which means it is not included. The other way you could have written this one would have been writing it without the element of r. So you could have written this as x and then the interval. But with this one, the interval part, the -3 to 6, has to look like that. There's no other options there. All right, so example 2, we've got this. Suppose a is equal to, and then we have this lovely bit of information here. I'm not going to say what it is right now because that is part A. Write the meaning of the interval notation, and that is telling us to write it in words. So here we have the set of, and we need to look at, are we looking at integers, real numbers, natural numbers? Which one is it? It is z, which means it is integers. So the set of integers such that, because that's what the straight line means, x is between 0 and 7, including 7. So just something that gives us that information in a sentence. Part B lists the elements of A. I'm just going to do this next to part B. So A would equal, what are the elements of A? Now it's between 0 and 7, including 7, but not 0. So it would start at 1. And we'd have 1, 2, 3, 4, 5, 6, and 7. Part C, find NA. So how many do we have in A? Count the numbers up, and we have 7 numbers in there. Part D, I'm going to do at the bottom, represent A on a number line. So I'm going to draw my number line first. Now it needs to go between at least 0 and 7. And then it's integers, so we're going to put dots on the line of the numbers that are included. And that is the end of this video.